Hey guys, today we're going to start our unit on organic chemistry, and you'll find that this is probably one of the more fun units in chemistry because everything that you need to know is in your reference table. So, good, I'm hoping you got your reference tables, because I got mine. Now, we're going to open it up to table P and table Q. So for this activity, until later on in the week, we'll be looking at P and Q. So get that out. Basically, what we're going to do is we're going to figure out how to name organic compounds. So there's a few different things. We have the naming, and then we also have the drawing. So a couple things about carbon, first of all. Write this down. Carbon is one of the only elements that can form long chains where it bonds to itself. You're not going to find this with oxygen, you're not going to find this with helium, you're definitely not going to find it with helium, but you're not going to find it with sodium. No element that you guys need to know about anyway is going to form long chains with itself. So, except for carbon. Now, the other thing you need to know about carbon is, since carbon has 4 valence electrons, carbon can only form 4 bonds. That's it. Carbon does not form additional bonds. So carbon will either have 4 single bonds sticking to it, so 1, 2, 3, 4, or it could have 2 double bonds sticking to it, or it could have a triple bond and a single bond, or it could have a double bond and 2 single bonds. Point is, 1, 2, 3, 4 bonds maximum. No more, no less, always 4 every time. Carbon never fails. Now, so get out your reference table. We're going to look at the difference between an alkane, an alkene, and alkyne. So, what you're going to look at is, according to this reference table, if it has the ending ANE, you're going to see ANE is going to tell us that it is an alkane. And all that means is it is a saturated hydrocarbon. What does saturated mean? Well, saturated means that you can't get any more H's attached to it. That's basically all it means. Everything is filled up. Now, alkanes are saturated. This pent tells you the quantity. In fact, I'll do it another color. Pentane. Pent is the prefix. You're going to look on table P and find out that pentane means 5. So if I asked you to draw pentane, you're going to draw first things first. Because it's an alkane, you know that it has all single bonds. So 1, 2, 3, 4, 5, all single. 5 because of the pent. All single because of the ane. Single, 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 single. All these single bonds. The last thing you're going to do is add your H's. Now remember, each carbon needs 4 total bonds. This carbon already has 1, so you're going to add 2, 3, 4. Now second carbon has 1, 2, 3, 4. This third carbon has 1, 2, 3, 4. And the fourth carbon has 1, 2, 3, 4, and finally the last carbon, 1, 2, 3, 4. But we're not done. Don't get lazy. Write in the H's. Okay? Now, the formula is going to be C something, H something. Now we're going to look at your reference table in this column right here where it says general formula. This is C to the N. And H is 2N plus 2. Now the way you're going to figure this out, even if you didn't want to draw this, you could write down C, because it's pentane, we know that it has to have this formula, N and 2N plus 2. So pent means 5. Now this is 2 times N plus 2, or 2 times 5 plus 2. Which is 10 plus 2, which is 12. So we write a 12 there. The other thing you could do is go 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's your 12. So pentanes, pentane, alkanes, single bonds. Pent tells you 5 carbons. This is the formula. Now let's look at this one. This is a little bit different. We're going to go backwards. So instead of getting the name and writing the formula, we're going to have the formula and we got to figure out the name. So first things first, we want to figure out, is it an alkane, an alkene, or an alkyne? So you're going to look at the structural formula. You'll notice in the alkanes, you have single bonds only. In the alkenes, you have a double bond. And alkyne, you're going to have a triple bond. So we look right here, we see a double bond. So that tells us the ending is ENE. Now, we're going to count 1, 2, 3, 4 carbons. We're going to consult table P, and that says bute. It doesn't say but. But has 2 T's. This is bute. So it is butene. However, there's a possibility that this double bond could be here and not here. So we want to specify exactly where that double bond is found. So we're going to number the carbons from the left to the right, and we're going to see, this is carbon 1, 2, 3, 4. So if I look right here, this looks like it is on carbon 2. 1, 2, 3, 4. So it is a double bonded carbon. So potentially right now, it is 2-butene. But I want to make sure, and I want to count it from the other end, just to verify that that is going to be on the smallest number. So I count from the right end, it's going to be 1, 2, 3, and 4. Now if I look here, on the second carbon, there is a double bond. So what we're going to do is we're going to actually keep this, and this is 2-butene. I'm going to come back to explaining, we're going to do a lot more work with this kind of stuff. So this we're going to come back to, and we're going to evaluate other possibilities of naming and numbering. Okay? So let's hold on to that for now. Let's go down here to 1-butyne. So first things first, we're going to look at table Q, and we're going to find out with Y and E, this is an alkyne, and then the number here, the BUT, tells us that there are, again, 4 carbons. So we're going to do 1, 2, 3, 4. Now, I know that there's a triple bond. That's what the alkyne stands. That's what the alkyne means. And I know that it's on carbon 1. So the triple bond is on carbon 1, just like the double bond was on carbon 2. This one has only single bonds, so that's why there's no number in front. So we're going to go ahead and on carbon number 1, we're going to draw a triple bond. Now I have this carbon right here has 1, 2, 3 bonds, so we're going to add a 4th bond. You'll see it drawn this way because this is how it looks like in nature. However, if you draw it coming out the top, it's okay. You're not going to get it marked wrong on the regents. Now looking at this carbon, we have 1, 2, 3, 4 bonds. So this carbon doesn't get any extra hydrogens. This carbon right here has 1, 2, and you need to add 3, 4. And this carbon at the end has 1, 2, 3, 4. Now let's just look at the name of it, butyne. Because it's an alkyne, it should have the formula of CnH2n minus 2. Or in this situation, C4H2n, which is 8, minus 2, which is 6. Again, N, 2n minus 2. So C4H6. 1, 2, 3, 4. And finally 1, 2, 3, 4, 5, 6. This one checks out. Now, we are going to run into some problems when we look at some of these. Because let's just picture we turn this around. So let me get rid of the name right here. Let's just get rid of this. Let's look at the same exact substance. One, two, three, four. Now, there is a wrong way of naming this one if you're given this one right here. Because I could start at the left and count the carbons. 1, 2, 3, 4. And if I wrote 3, because it's on carbon 3, butene, and this one wrote 1 butene, this would be the wrong answer. Because remember, I told you to count from the shortest end. So if I started here, 1, 2, 3, carbon 3, 4, or I started on the other end, 1, 2, 3, 4. This is actually 1 butene. Okay, let's do one more thing right here, and I'm going to ask you to name something for your practice. Okay, so we're going to have 2 questions. Question A, question B, question A. Name this. Question B. Draw this. And that's it. Peace.